Hi, Quinn. Hi, Quinn. Can you hear me? Is that any louder? And I should be able to hear you if you talk.
Hello.
Hi. How's it going?
Good.
Are you watching video as well or just listening?
Um, Watching video, I think.
Great. Okay. How's it going?
Good.
How was
School
Lard?
starts at 7.
Yeah. Hopefully everyone got the email about the change of the link.
Mm-hmm.
Were you able to get in okay with the new link?
Yep.
Cool. Are you on a laptop or a phone or what?
I'm on a desktop.
Cool. How was Largemont today?
It was fun. But I mean,
Yeah.
we didn't really sell today. The regatta was pretty good though.
Yeah.
Yeah.
Yeah, part of the fun is sitting around on the lawn, right? Waiting for the wind or waiting for storms to pass.
Yeah, that's pretty much Larchmont Race Week.
Yeah, there's always too much wind or too little wind. That's how it goes.
Yep.
How was the dance?
It was good.
Yeah. So are you taking the basic or the advanced test?
Um, I guess basic. I don't know.
Mm-hmm. Were you on one of the lists where they said these people are taking the advanced or anything like that?
I don't think so.
Okay. This is your first year doing the big boats, right?
Yes.
Yeah. Okay, cool. All right. Well, we should have people joining eventually. So,
Is that Maggie?
Yeah.
Hi, Maggie.
Hey, Quinn.
how you doing, Maggie?
I'm good. How are you?
Got the link okay, I guess.
Yep.
Hopefully, everyone does.
I'm talking to a couple people right now, and they're all trying to figure it out, but I think everyone's coming on soon.
Great. I know Will was on earlier, so any help you guys can give would be great. Maggie, how'd your Largemont race week go?
We didn't do as well as we could have, but we enjoyed ourselves, so
Yeah.
yeah.
Hey, Charlie. I think you're on mute, Charlie, if you want to join the chat.
Big turnout.
Getting there.
Weird, the screen keeps switching around, different faces.
Yeah, so I think it sets up for who's ever speaking. I'm trying to figure out if there's a way for it to... Maybe what I just did locks it on me. We'll see if that does anything. Are you guys seeing me right now?
Yeah.
Mm-hmm.
Okay, we'll see if it switches around. So obviously, as we get going, I think there's both the chat and the Q&A app. So feel free to throw any questions in or just ask out loud.
Okay.
Hi, Oliver. I think people are on mute when they first join, but if you want to unmute, you can.
One person's just a picture of a dog.
I think Quinn prefers to stay anonymous.
Yep.
Smart man.
Charlie is seductively eating ring pop. It's really freaking me out. Ooh, Reed's here. Now it's a party.
I wonder, Charlie, if maybe your mic's not set up or something, and so it won't let you add audio. So you'll just have to type to us. How's it going, Reed?
Good.
Did you dodge the storms today?
It might have something to do with the hiding participants thing that you did before. Might not
What's
let
that?
them talk.
What's that? Yeah, it seems like a few people are getting stuck on mute, and like I can mute and then unmute Quinn, but I can't unmute some of the other participants. So that's all right. Just if you have any questions, hit up the chat. So we'll give people just 1 or 2 more minutes just to see if we have any more people joining. All right.
I'm gonna have to leave for a second. So I'm gonna try to pull this up on my computer.
Okay.
Yeah. Be right back.
Yeah, I don't think it's a number of people, because if I mute Quinn or anyone, it doesn't let me unmute others. So in Cameraman, I just turned off hide. I didn't want it flashing around everyone's video, but maybe that will do something. So while we're waiting for people, if people want to throw any topics in the chat that they think they want to review, especially people doing the advanced course, that's going to be the plotting and chart work after the multiple choice. So feel free to throw anything in there. One thing we haven't talked about, which is part of the course, is weather. So if anyone has any weather questions, that'll be something we'll talk about tonight. So they're sending out a link that you guys have to do the regular test online tomorrow night within a certain window. Is that what you're saying, Charlie? Okay. So have they sent any of that info yet? It's pretty last minute, I guess. Okay. So I think the storms that were rolling through Largemont are up here now. So we've got all kinds of thunder and rain around here. Okay, good news. So you have all week to take it. And I guess it's open book, so that shouldn't be too difficult. Okay, so let's get started. I guess if no one has any questions, we'll do a little bit of discussion about weather. We'll talk about set and drift and some of the drafting stuff. And then, as I said, feel free to chime in anytime in the chat and let me know any questions you have or anything you want to back up and review, and we'll just go through it. So weather. I think what will be easiest there is, why don't I do a little screen share and see how that goes. So So this is a good diagram of a typical weather map, right? So what we see here is obviously the U.S., and we see some H's, which stands for a high, and the L's, which stand for lows. And then we see these lines along here, which are fronts. And there's two types of fronts. There's cold fronts, which are blue, of course, and there's warm fronts, which are red. And so what the red down here means is that there's warm air moving up from the Gulf of Mexico up into the southern U.S. And what the blue here means is that there's a bubble of cold air here in Colorado that's moving south into Texas. So if we go to today's surface analysis, so the surface analysis is what the forecasters use to indicate what they think is the pressure and the different fronts on the surface today. So what we can see, this is kind of low res, but hopefully everyone can see this. So what we have here is the east coast of the U.S., and if we see this blue line here, this is that cold front that came through this afternoon. That caused all those storms that you guys had and canceled your racing for the day. Then what we have behind that is these high pressure bubbles out here over Michigan. And so what we're talking about here is the air pressure, which is measured in millibars. Sorry, let me just stop the sharing. So you can think of the atmosphere, you know, this is the Earth down here, and then there's all this air piled up on top of you, right? And we know that if you were going underwater, the deeper you went underwater, the more pressure you're under, right? Just like a submarine. And so the same thing applies to the air. So the more air you're underneath, the more pressure there is. So when you're sitting down at the surface of the Earth, if you're under a big pile of air, you're going to feel high pressure. And if you're under a low pile of air, you're going to feel low pressure. And so that means that you can think of a high as where the air is really stacked up high, and a low is where it's stacked up low. And you can imagine that it's like a wave in the water, right? So it goes from the high to the low. And where's the air going to flow there? It's going to flow downhill from high to the low. So those highs and lows are what create all of the wind all over the globe. So generally, you're going to get some high pressure, and high pressure is good weather because the air is kind of flowing gently away from the high. And the low is like, think of a low like when you're draining your bathtub or flushing the toilet, if you want something more graphical. So it's like this pit where the air is flowing into it, and as it goes in, just like in a bathtub, it starts to rotate. Yeah? And anyone ever see the Simpsons episode about, does it rotate the same way in the north versus the southern hemisphere? So there's all this stuff about the Coriolis effect, right? So we've heard of that. So in the northern hemisphere where we are, because of the way the Earth is rotating, when the air flows into a low, it rotates counterclockwise. So what do we call, you can type the answer in, a really deep low? Think of a big storm where wind is rotating counterclockwise. All the weathermen go to the coast and they stand in their weather jackets and get blown around. Tornadoes one, so we can talk a little bit about what causes a tornado, but hurricane is your typical deep low pressure system where the winds are rotating around. So even a regular low, like if we go back, let's try the screen share again. So if we go back here, we can actually see that up here is a low pressure. So typically you have, hopefully you can see my cursor so you can see where I'm highlighting, but this low pressure up here, the cold fronts typically get drug along by the low pressure. So what you're going to have is air flowing from this high into the low, around the low like this. And so I would bet if we looked at a sail flow forecast right now that we'd have some westerly winds blowing from the high to the low. So a tornado is a good example of sort of a more extreme version of this. So that gets into more local weather, right? Hurricanes cover hundreds of miles, whereas tornadoes are very small and localized under a cloud. So also, good Sam, typhoon is actually just another name for a hurricane that happens in the Pacific. So what happens locally with weather? We've got these big weather systems rotating around, right? But then locally we know that, you look on the Weather Channel tells you the certain wind, and we all know sailing on Long Island Sound that the wind is kind of, it does whatever it wants to do, right? So Long Island Sound has all kinds of local effects that the larger weather systems don't really account for. So when we talk about local wind, one of the big things that you've probably heard about and talk about all the time in sailing is a sea breeze, right? And so what happens with a sea breeze? You have a mass of land here, right, and an ocean or water over here. And the land is warmer than the water. So hot here, cold here. And just like a pot of boiling water or a radiator where you see the heat rising off of a hot surface, that's what happens with the land. So the air starts to rise up off of the land and move upward, and that creates a space down here that sucks in the air from the sea and causes a sea breeze. So you get this circulation up and then back out to sea and then sucking in. So when the I'm liking the apps. This is good stuff. So when the air rises, it has moisture in it, and that moisture rises up and forms clouds. So then you get a cloud that forms, and as more air moves up and more moisture condenses into a cloud, you get those big, dark thunderstorm clouds. So it starts thundering and lightning, and what actually happens is they grow so tall, so really tall, and they're called cumulonimbus clouds, that the top actually starts to freeze, and it gets so cold that it starts downflowing, and the whole process reverses, and you get this core of cold air that starts flowing out of the cloud and hits the ground and spreads out into what's called the downburst. And sometimes you have that come down and it starts spinning at the same time, and that's when you get a tornado. On the water, that's less frequent. In fact, the sort of Midwest of the U.S., where we get all those tornadoes, is one of the rare places in the world that really gets tons of tornadoes. They're not really common elsewhere in the world. But on the water, you can get a water spout where the tornado actually comes down and it starts sucking water up. And then that you can actually see that off in the distance, this big spout of water rising up into the clouds. Obviously something to avoid. So quick weather overview is basically that you have medium size type events that are highs and lows, and the wind goes counterclockwise around a low, and the sea breeze is basically a mechanism that sucks the air in from the sea into the land. Now, has anyone heard anyone talk about the sea breeze in Long Island Sound and why it's not really consistent, and some days you get a nice breeze in the afternoon and some days you don't? So what can happen with the breeze on Long Island Sound is that Long Island itself gets in the way. So you can think of Long Island Sound as two masses of land. So you have Connecticut over here and Long Island here. And the breeze comes in from the ocean and it hits the air over Long Island, and it goes up because it's rising like a sea breeze does, and then it continues on into Connecticut, but maybe the wind is all the way up here and it goes right over us sailing on Long Island. So what actually has to happen so this is Long Island Sound over here, and what has to happen for the sea breeze to make it to us is that it has to, instead of rising up over the thermal of Long Island, it has to break through that thermal and hit Long Island Sound itself. So something you can look for is clouds over Connecticut mean that they're trying to form a sea breeze, but if there's clouds over Long Island, those might block the sea breeze, and then you can blow through, and when those clouds go away, then the sea breeze can come through onto Long Island Sound. So that's one of the reasons why Long Island Sound sea breeze is so inconsistent. The last thing we'll talk about with weather is we will just talk about really global weather. So on the screen right now you see a nice globe, and what you see are these cells of circulation. So just like we have the sea breeze close to the Connecticut shore, we also have the equator down here, right, that goes around the middle of the Earth. And we all know that down on the equator it's really hot. So you've got the you've got the tropics, and you've got the sun beating down. And so the air is going to rise up off of the equator and flow northward into the poles. Now, it's a little more complicated than that because you see there's these sort of 3 cells at different latitudes. And we sort of live under this mid-latitude cell, and there's the Hadley cell. But the important thing is that it's basically the same mechanism, that the air rises over the tropics, it goes up to the pole, and then it comes down to the surface, and it blows from north to south. And because of the spin of the globe and the Coriolis effect, as it comes down, it kind of comes down straight up here, but then by the time it gets down to the equator, it's kind of like a spinning top. That's the fastest moving portion. And so it's going to go to the west, and so that shows up as an easterly. And we get the trade winds that are very consistent in the tropics, and you can go down to the Caribbean, and you have northeast winds at 10 to 20 knots every day, all year round, pretty consistently, unless some sort of little storm comes through. Whereas up here, we get much more mixed weather. But the important thing is globally, it's the same effect as the sea breeze. You get air rising from the tropics and moving up to the poles and flowing down south and creating those trade winds. Now, right at the equator, it's like being right under the cloud. You can think of the air as moving straight up, and we get what's called the intertropical convergence zone, if you want to use a complicated weather term, or the doldrums, or the French call it the black pot. But it's an area of very little to no wind around the equator. So when you look at the round-the-world races like the Volvo or the Vendée Globe, they sail down in very nice, consistent trade winds, and then they've got to figure out how to get across this band of no wind, because you've kind of got the southerly breezes coming up and the northerly breezes coming down, and they hit each other and create this area of no wind that's known as the doldrums. So that's something that people sailing around the world have been dealing with for a long, long time, and it's a big part of racing tactics now. So that's weather. Glad to see that everyone's picked their outfit and their uniform. It tells me a lot about everyone based on what you're choosing. So we'll note that in the attendance on what everyone decided to dress up as. So that's a really brief overview of weather. 2 more things that I'll point out. We mentioned warm and cold fronts. So a cold front is where you have cold air moving into an area of warmer air. So that's what we had today. We had that cold air coming from Michigan and flowing into the area and causing storms. Cold fronts are usually the more sort of active and sudden. So because of the way a cold front works, right, cold air is heavier than warm air. So this is the cold air here, and this is the warm air here. And as the cold air comes in, it kind of acts like a plow. It moves in underneath the warm air and lifts the warm air up. And so when a cold front moves in, what you see is this band of clouds that builds as the air is rising. You get this sort of wall of clouds that moves into your area, and there's often a lot of rain and thunderstorm activity under that cold front. And it's usually pretty short because it's a very quick moving thing, and you're going to get a big wind shift when that cold front comes through. Now, warm front is exactly the opposite. Because the warm air is warmer and lighter, it rises up over the cold front. And then also, there's a big difference in the slope. So cold front kind of comes through really steep and creates a lot of cloud activity right on the front. A warm front, on the other hand, is really shallow. So what you have is this warm air gradually rising up over the cold air down here. And you get the same thing. You get these wispy clouds here, and then gradually building to more clouds, and it might start raining, and then it keeps on moving down here. and eventually you get through to the warmer air on the backside. So a cold front moves through in a matter of a couple hours. A warm front can take a whole day to move through. So it's a much more gradual process of gradually it starts raining a little bit more, then it rains all day, then it gets cloudy, and then finally it's come through. So that's it for weather. So we'll go back to the review. So one of the questions, and obviously one of the topics we went through quite quickly last week was plotting and our course and our set and drift and all that kind of thing. So what we saw last week was we plotted our course, and the length of our plot was our velocity through the water, right? And our heading, magnetic heading, was the direction of that line. But then we saw that the current was going to set and drift us in a certain location, right? So we got here through the water, but then let's say we had current coming down this way. North is up, of course. So coming down this way, we have current setting us towards the southeast. The southeast is down here. So the set is the direction of the current, and the drift is the distance. So then we had a third line that was between where we started and the end of our current vector. So we have our line between where we end and our set and drift, and the stronger the current, the further it's going to push us, and the different direction, it's either going to slow us down by pushing us back where we came, like this, or it's going to speed us up by helping us along to get up here. So drift is the speed that the current is pushing us, and the stronger the drift, the bigger the difference between your boat speed and your course and where you're actually going over the ground. And someone can type in the acronyms for what we're actually traveling relative to the ground. So like what we care about when we're dead reckoning or we're trying to get to a mark. So SOG is speed over ground and COG is course over ground. Okay. So let's see, what else is there to review there? So who asked the question about drift originally?
Sam.
Was that Sam?
Yep.
So Sam, what are some of your specific questions about drift that we can address?
Good talk.
What's that?
He didn't respond. I said
He didn't
good.
respond. Good luck. He can type. Sam, I wasn't there. Okay. Okay. So let's do a quick screen share and see if I can find the presentation. Will, can you see the presentation?
Yeah.
Great. Okay, so this was our diagram that we used to explain set and drift and to do our plotting. So so what we have here is our course where we're actually steering, so from point A down at the bottom to point B at the top. So that's, let's say we're sailing at 8 knots at a straight north 0 degrees course. But as we're sailing, we've got speed and course of current, so set and drift, going from B to C, so in sort of a east-southeast direction. So if that vertical line from A to B is 8 knots, then it looks like we have maybe 3 knots of current going from B to C. And so what you do to plot this out is you find your location, which is A. You use your parallel rules and dividers to draw the direction and speed. So let's say you've been going 8 knots for 2 hours. Then your distance from A to B is going to be 16 miles, right? 2 times 8. And so you're going to use the rulers and dividers to draw that line, A to B. And then the current is going 3 knots. So again, over that same 2 hours, you've now got a 6-mile line. And if we know from an estimate like Eldridge or some current map that the current is flowing east-southeast, so sort of in the direction from B to C, then we're going to draw the line B to C with a length of 6 miles, 2 hours times 3 knots. So over the course of 2 hours, the current's going to push us 6 miles. So now we've got the vertical line, A to B, which is how far we've traveled through the water based on our heading and boat speed, right? So that's the distance, speed, time triangle, right? So boat speed times time equals distance, and so that's A to B. And then same thing for B to C. The current pushes us from B to C, so we can just draw those 2 lines, and then we connect them with the third line, A to C. And the length and direction of A to C, which we can read off with our dividers to measure the length, and we can use our parallel rules to take the angle of that line and move it over to the compass rose and get the angle. And that is going to be our course over ground and our speed over ground. So you can see that the stronger the current is, the longer the line B to C is, and the more difference there will be between where we're actually steering the boat, our true course, and our cog and sog. So that's a little review of the plotting that we did last week. So hopefully that helps out with the set and drift. Okay, yep. So Will on mute fixes that. Good call. Sam, did you hear that okay? Great. Quinn, does that mean you have a question, or you just have lots of questions in your head?
I don't know.
Okay. So what else can we talk about? There's we can go through the whole presentation, but I'd rather answer questions you guys actually have than just go through all the pages. Okay. Great. Okay. Okay. What even is dead reckoning? So maybe while I'm talking, someone can type in the more technical term that. Sorry, Charlie. Current plotting. Yeah. So what do you mean by current plotting? So the current plotting, I think what you're referring to is the diagram that we were just talking about. So in this diagram, we have the line from B to C is the effect of the current. So in this example, that current is flowing east-southeast if the top of the screen is north. So the example here would be you're sailing down Long Island Sound. You're going north, and we know that when the current is flowing east, that's an ebb, right? The current's flowing from New York towards the exit of the Sound out by the race. And we look up in Eldridge, and we see that the area we're sailing in, it's flowing at 3 knots. And it's flowing in an east-southeast direction, so we can make an estimate of the angle. And then we can just draw that on our chart based on the distance and the angle that we've estimated for the current. All right, let's kill this. Right, so how does the weather come into the small scale, what's on your test? The answer is I'm not really sure. I haven't seen the test, so it's a very brief section online. So you'll want to make sure to do the online course and look at the weather section there. There's not too much more in there than what we talked about, if anything. I think we probably talked about a little more than what's in there. So take a look at that section. I think there'll just be 2 or 3 questions in the multiple choice thing that cover weather. So it's probably not a huge deal. But the main thing is for navigation to keep in mind is when you're preparing for a race, so like the day before your beach point race, you're going to be out there and you can't necessarily go straight to shore the second the breeze comes up. So you want to be aware of what's going to happen over the next 24 hours. And if there's a cold front coming through, that means that there might be some severe weather coming. If you look at the wind forecast, that'll tell you sort of the minimum and maximum wind that you can expect. But anytime a cold front is coming through, it can get gustier and it can get thunderstorms, and thunderstorms can bring through, really sharp, short bursts that aren't going to show up on the broader forecast. And then once you're on the race course, then it comes down to thinking about things like sea breeze and what might happen based on more local effects. So weather is kind of, for navigation, it's pre-race preparation, knowing what might happen, but then also thinking while you're on the boat, okay, what effects am I seeing? If I see this line of clouds coming, well, that's the cold front that's forecast. And when that cold front comes, there's probably going to be some really strong wind, and we have to be ready for that.
We got it, Mom.
Hey, how's it going, guys?
Where's order?
All right. You guys are loud, so I'm just going to mute you for now. You can come off mute, though, if you have a question.
Hello.
All right.
Queen.
Okay, so Camille asked, what even is dead reckoning? So who remembers the more technical term for dead reckoning? It has the same acronym.
When we need to ask the truth.
So dead reckoning is also called deduced reckoning. So what this means is you are working on trying to figure out where you are based on where you were at a certain time and what direction and course you were going. So the basic concept is pretty straightforward. If you know you're at a certain point and you know you're headed in this direction and you know that you're sailing at about 8 knots and you're sailing for 2 hours, that means you're going to go 16 miles in this direction. So the point of dead reckoning is if you've lost your GPS, because obviously GPS is the easiest way to find out where you are, then you can use dead reckoning to figure out where you might be. So it's always going to be an estimate, right? You're never going to be perfect about exactly where you're going, but certainly an estimate is better than just saying, I don't know where we are completely. Now, Charlie brought up a good question. It's the 3-point thing, right? So that's actually slightly different. So deduced reckoning or dead reckoning is saying, okay, I know I was here, and I know I was sailing at a certain speed and distance and direction, so I'm guessing I'm going to end up here. So deduced reckoning is saying, based on how fast I'm sailing, where do I think I've ended up? You know, if you're in Noroton and you're sailing east and you sail for a couple hours, you're probably somewhere off New Haven. You know, that's just a good guess on where you are. The 3-point thing is called the 3-bearing fix, right? So that is where you're trying to figure out where you are now, and you have the benefit of being able to see land. So if you recall, what we do here is we look at the chart and we say, okay, I'm approximately here, like, you know, I'm off Noroton, so I can see the end of Long Neck Point, I can see the Noroton flagpole, and I can see, you know, a green gong off of Norwalk or something. And we look at those points on the chart, and we use a hand-bearing compass, you know, that we hold to look up. And we take a bearing from our boat to those 3 points, and then we look at those bearings on the chart and we draw them out, right, and we get some lines. And so we really only need 2 lines to find out where we are, right? 2 lines cross at one point and we're on that point. But as we know, we saw when we did our plotting exercise, you're never going to get your bearing exactly right. You're going to be off by a couple degrees, and when you plot, it's going to be off by a couple of degrees. So more often what you get is some sort of 3 lines, and they form a triangle, and your boat is somewhere in the triangle, right? Because there's some error, and so your best guess is that you're in the middle of the triangle. So 3-bearing fix is you're within sight of land or you're within sight of buoys, and you use that to figure out where you are. So 3-bearing fix is where we are. Okay, guys. Let's not take advantage of the sound effects, although I do like the applause. So 3-bearing fix is figuring out where we are. Deduced reckoning is, I know I was at this point an hour ago. Where do I think I've gotten now? So does that clear that up, Charlie? Okay. So some of the things they're going to ask you on the test for the plotting section, and this really gets to you know, what you would do preparing for a race, like if you're doing the Beach Point overnight race. They're going to give you a list of marks. And those marks are going to be buoys around Long Island Sound, and you're going to find those buoys on your chart, and then you're going to want to find the range and bearing between each of those marks. So someone can type in range. What's range? And someone else can type in bearing. What does bearing mean? That's a good question, Oliver. So I'm not I think you guys, the online questions are probably going to involve you having that training chart in front of you, and the online questions will ask you certain things, and then you'll have to draw on the training chart and then input the answer. I'm not sure about that. Again, I haven't seen the test, so I don't know exactly what they're going to ask. But I don't think it's going to be clicking around a chart online. I don't think there's any way that they have anything that fancy. So when you get the link, you guys will want to find out whether you need a chart to take the test or not. If you don't need a chart for the basic test, it's probably going to be easier than that. So so it shouldn't be too big a deal. Which tool, ruler, do we use on the chart to find the bearing between 2 points? What are the two main tools that we use for plotting? So parallel rules, good, Oliver and Sam. So those help us walk a bearing, right? So we've seen that demonstrated where you have the angle between 2 points, and we walk the dividers over to the compass rose and measure what that bearing is. And Maggie's got the other tool that we use, which are dividers. And so dividers are just a easier to use ruler. So if you ever don't have dividers, you can always just use a ruler, or you can use the edge of a piece of paper or anything like that to mark off the distance. And then we have to figure out, okay, that's 3 inches, but what does that actually mean in terms of distance on a chart, right? I think we can remember from last week that lines of latitude are always the same distance all the way around the world, right? So whereas lines of longitude get closer up near the poles. So latitude are always the same distance apart. They're always 1 degree apart, and there's 60 minutes in 1 degree. And then we remember that one degree equals 1 nautical mile. And a nautical mile doesn't equal a mile on land like we have in our car, because we've set it to be related to latitude. So whenever you have your dividers or a ruler, you can measure the distance between 2 points by comparing that to the number of minutes between those 2 points on the chart. And so every so lines of latitude run horizontal, but the scale that we want to use is the vertical scale on the side of the chart, and we measure the minutes on that vertical scale. Yeah, so that's how we measure the distance, and we use the parallel rules to measure the bearing by going to the compass. And then we reviewed it a bunch of times, so you guys all remember the compass is going to show you 2 different types of bearing, right? You're going to have true, and you're going to have magnetic. And magnetic is different from true based on variation. And so the variation is going to change depending on where you are in the world and the time of the year. So it drifts a little bit, a few tenths of a degree every year. So in the middle of the compass rose, there's the center, and then around that, written in a circle, is the variation, right? We all saw that on the different charts. So you always want to make sure to be thinking, am I talking true or am I talking magnetic? Now, usually, it's always going to be easier to talk magnetic, because magnetic is what your compass reads, it's what your hand-bearing compass reads, it's what your GPS is going to read out for your course over ground, your COG. So true is kind of nice to know because it's what you're actually pointing relative to the world, but the real key that you want to be telling people on deck, so if you're telling someone, okay, our next mark is at 70 degrees, the assumption is that you're talking 70 degrees magnetic, so that they can just look at the compass that's down on the wheel and they can drive to 70 degrees. So that's key, that you're always working in magnetic. So they're going to ask you range and bearing between a number of marks. And then they're probably going to have you do the set and drift exercise, where you've got two sides of that triangle, either your boat speed and heading and your cog and sog, and ask you what the current is. Or they're going to give you your boat speed and heading and the current and ask you where you end up or what your cog and sog is. So given any two sides of that triangle, you can always solve for the last. Yeah, so that's usually the tough one, right, that they try and get you with at the end of the test, is the set and drift. So what you can do, you know, I know this isn't exactly what you guys are looking to do on your Saturday, but for those of you taking the advanced test, you know that it's a requirement that a certain number of you pass that to get on the boat, and you know, we have to do it. So to get the whole team on the water, those of you doing the advanced test, you may want to make up a few pretend problems on your own. I can also email around pretend problems if you guys like. Just let me know. Shoot me an email. But really, you can just take a chart and say, okay, let's say I was heading at 8 knots on this course. Let me draw that pretend line, and then let me make up a current and assume, okay, let's see, if the current's doing this, then where do I end up? So yeah, I can definitely email you around some practice problems. I'll take a look at the Western Long Island Sound chart and see what we can come up with. So I'll email them around to the whole group, because those are tough. So we'll practice a few of those. The one thing we didn't talk about in the plotting exercise that's good for review is just simply finding latitude and longitude, or given a latitude and longitude, finding a point on the chart. So that's pretty basic, but it pays to go over it. So what you're trying to do there is just think like the world is one big piece of graph paper, right? And so we know when we're doing a graph in math class, you've got your y-axis and your x-axis, right? And in our world, our y-axis is our latitude. It's how far we are north to south. And our x-axis is our longitude. It's how far we are east to west. And we also remember that the prime meridian is 0 and the equator is 0. So if I'm up here, then I'm positive latitude and positive longitude. And if I'm down here, I'm negative latitude and I'm negative longitude. And we label those, if you remember, positive of the equator is the north, of course, negative is the south. And then with the longitude, that's over England. And so we're over here, I guess, over here, looking your way. Actually, no, it's not mirrored. So we're over here to the west of England, right? And so that is, your longitude is going to have a W after it to signify that you're to the west. So if you're given a latitude and longitude, you want to find those on the scale of your chart. You know, so you find your longitude on the bottom scale of the chart, and you find your latitude on the vertical scale, and then you draw two lines, and where they intersect is where that latitude and longitude is. And then conversely, if you just have a random point on the chart, you want to draw a perfectly straight line over to the vertical scale and find the latitude, and then also draw a perfectly straight line to the longitude scale and find the longitude. And the way we do perfectly straight lines is we use our parallel rules. We find a line of latitude or longitude, the grid lines on the chart, right? And we walk a straight line down so that we know that it's perfectly straight. So that's just latitude and longitude. So they'll probably give you some of those. They'll say, okay, if you start at this latitude and longitude and go in this direction at 8 knots for 2 hours, at 90 degrees true, where in the world do you end up? And so that's a useful practice problem too. I can email something like that around. So it's been an hour, and I know it's getting late, so I don't want to take up too much time, but I want to make sure that that any questions have been answered, and particularly for the people taking the advanced test. I haven't looked at who's been making progress online, so I can take a look at that and see. Hopefully everyone has made progress through a lot of those sections. So it sounds like the basic test comes out tomorrow, Thursday, and you guys have a week to do it. So the basic test should be pretty straightforward, obviously. You know, all the stuff about the, you know, green and red marks, cans, and things like that. I think you guys remember all that, right? Red marks, red right returning. Green marks are kept to your left, and they're odd numbers. The numbers get bigger the further into port you go, all that kind of good stuff. So that's going to be some pretty, you know, just multiple choice questions, which you take online. The advanced test, I do not know where that is. I think someone might have mentioned Riverside. Does anyone know? Is it on Sunday or something, and it's at Riverside? Yeah? Is that right, Maggie? Okay. So I think that's Sunday the 20th, right? Sometime at Riverside Yacht Club. So, Monday, great. Okay, so Monday evening. And then I think they don't have a time, but they're trying to schedule a makeup test for people who are at 420 Nationals. But they don't know when that's going to be. And so, yeah, Maggie's right. I think that's going to be at Noroton, but they don't know when. So it's up to you guys if you want to drop off. If anyone wants to stay, we can reduce the usage of mute, and we can have a chat about any questions. If anyone wants any extra help, we can do that. And you guys have seen, you know, all the stupid number of emails that were sent around today. So please feel free to email me if you have any questions, and we can do some review on any questions. So, okay, Jim. All right. So the people that are staying, anyone have any further questions?
Hi, Maggie.
Maggie, were we able to get you off mute? Let's see, show and broadcast.
Oh yeah, it works.
Ah, there you are. Yep. Okay. See who we can add. Oliver. Quinn's on. And Sam's still with us. Is Camille on? Can you hear okay?
Yep.
Okay. And Charlie, show and broadcast.
Okay, Oliver.
There we go.
What a narc.
Okay. Sam, working on you.
Yarn.
Okay. Anyone who wanted to stay? Anyone have questions that they want to discuss?
Charlie, you've been eating that for like an hour.
That is a very important question. Thank you for bringing that up. Good. Camille, can you hear us? You were in and out a lot during the review. Did you have any questions?
Nope, just what Death Reckoning was, but I got it.
Okay.
Ooh.
So, how did you guys feel about the plotting exercise that we did last week? It was a lot to do in the section, but do you think it made sense in the end?
I think it was really helpful to do.
Yeah.
It was.
Has anyone done that on an actual chart? So rather than having that blank piece of paper? Probably not. So you guys are back at Noroton tomorrow, right?
Yeah.
So you guys know those charts are upstairs. So I don't know who owns those, but I'm sure it's okay if you grab one if you guys want to do some work in preparation for the test. What is Reed doing here? Reed, are you like in a dark basement, hiding from your parents?
This is my room.
This is your room. You're just like sitting in the dark.
Yeah.
All right. Quinn. Nice bookcases.
Ryan.
Where's Ted?
All right. So, any questions, guys?
Ice cream on my face.
I don't have any specific questions, but I feel like I don't know, I should like know more than I do.
Well, look, this is meant as an intro to navigation. Navigation is a big topic. It's been around for many, many years. So, yeah, there's, of course, more to learn. But, they're going to be taking the questions from that online, all those online modules. So if you've gone through those and you've done the pop quizzes and all that kind of stuff, you'll have it pretty well covered. So obviously anyone who's going through that, again, if you have any questions, email me, and and then I can discuss the answer with the broader group in case anyone else had the same question. So so just feel free to be in touch if you guys are reviewing. Yeah. What's you guys' next regatta?
Pequot.
Pequot.
Nationals.
Nationals.
Nationals, yeah.
Where are 420 Nationals?
Newport.
Newport.
Cool.
New Year.
That's where I am. When are you guys coming up here?
I'm leaving Monday night.
Sunday night. Does racing start on Monday?
Tuesday.
Tuesday. Okay. Cool. So I start racing tomorrow, and I race through Sunday. So we'll be finished up on Sunday, and then heading home on Sunday. So we won't overlap, but it's great sailing up here. And unlike the sea breeze in Long Island, the sea breeze up here is really consistent.
Yeah.
So pretty much every afternoon, you're going to get a 10 to 15 knot sea breeze. So be ready for that. Be ready for a bit stronger breeze.
Yeah.
And sailing in the bay, make sure you always know where the current's going, because the current is very strong north-south in the bay, and it can really pay to figure out which way that's going. So.
Jamie.
All right. So has anyone been in the online course, and has anything come up, either problems with the course or questions? Did someone say yes? Problems?
Yeah.
Is that Reed having issues with the online thing?
It's
No, that's
Teddy.
Teddy.
Oh, Teddy.
Teddy? So what's going on with it? What's causing problems?
It's not letting me sign back on.
So you signed in once, but then it won't let you sign on again?
Yeah.
Okay.
Maybe can you delete that? Oh, I didn't draw it.
Maddie couldn't get on, but she asked me to ask you a question.
Okay.
She wanted to know how to calculate deviation and variation. Or, which, yeah, that's what she said. Can you ask them how to calculate deviation and variation, or can you just tell, like, all of it?
Yep. Okay. So let me make a note because I'll email that around. But let's see, deviation, variation. So one thing to keep in mind, which you guys probably know, but those aren't things you calculate, right? They are just facts of life. So variation is true north is straight from the top of the chart all the time, right? But magnetic north varies by some amount, and that amount varies all over the globe. So true to magnetic is your variation, and that's just a fact of the world. They do use mathematical models to calculate it, but it's nothing you would ever calculate. It's something you would look up on a chart or go to a website and say, what's the magnetic variation in Newport, Rhode Island? And then it would tell you. Deviation, you'll recall, is the error in your compass. So it's the error caused by where the compass is in the boat and any metal that's in the boat. So deviation is the error. Variation is the amount that magnetic varies. So deviation you find out by you basically drive your boat around in circles and you look at the error. But it's something to know about. It's probably not something that's going to come up ever in real life. But you basically want to remember the equation that your true heading plus your variation plus your deviation equals your magnetic.
All right.
So I'll send out some review notes on that.
Okay, thank you.
Bye.
All right, so the drawing is fun. Any other questions? Quinn, Reed?
Yo, Spencer, everyone's knocking on me.
Yes.
What's that?
People keep drawing stuff on me.
Yeah, they're doing that to you?
Yeah.
That's happening to me as well. So
Maggie, why can't you get anything?
I don't know.
Maggie.
What?
I can't draw stuff on your face.
Good.
I think
look at this. Look at this.
if you're dumb enough to accept the drawing act, then you get drawn on.
Alright, wait two seconds.
Oh, Maddie asked one more question.
Okay.
Does variation differ in different places?
Yes, it does. Right. So, Maggie, we've talked about this, right?
Yeah.
What do you think? Yes or no?
Yeah, and isn't it on like the compass on the map of wherever
right.
you do?
So whenever you go to a new place in the world, you want to look at what the variation is in that part of the world.
Yeah.
Get over to Jamie.
So,
Stop.
anyone remember what the variation is approximately around Long Island Sound?
13 or 14?
Yep, that's right. I think it's like 14.3 or something like that. So that's a good number just to keep in your head. And you also have to remember that variation can be minus or plus.
Where's Matt?
So you want to check if it's a west, then you are adding that variation. Right. So if you're heading 10 degrees true, if you're heading 10 degrees true and the variation is 14 degrees west, then you're going to add that in. If it was 14 degrees east, you would subtract it out. So. Where did the sound effects come from? I wanna play.
That was not me. That was. I'm not. I'm not in.
All right. Is Quinn like the silent Jedi master of Google Hangouts or something? Is he the only one who knows how everything works?
But there's a penis on
All right, guys. That's enough for me if it's enough for you. All right. So, unless you guys have any other questions, we'll wrap it up.
I have one more question for Maddie.
Sure.
She said she's sorry she has a problem with her computer, but
Nah.
she wanted to know if you add the 14 degrees or subtract.
Right. So, okay, guys, keep it down for. Hey, if you want to leave, just leave. Okay. So that was the question of is variation east or west? So if you have Western variation, then you're adding it. Remember that was that really bad acronym, something about TV and dull children?
So,
TV makes dull children, adds wisdom. I don't even know why. So you have your true, then you have your variation, TV, then you have your deviation. So now you have TVD to get your magnetic, and if the variation is a westerly, then you're adding it to your true.
Okay.
So, and vice versa, if you're heading 20 degrees magnetic and the variation is 14 degrees west, then you would subtract that and your true heading is 6 degrees, right?
Okay.
Sister sound.
Oh, and she asked if it's per nautical mile or if it's just in general. I think it's just, like, in general, right? It's not
Say that again?
she's not sure if it's, like, per nautical mile or if it's just, like, variation is just a thing itself.
Yeah, variation is separate, except for the fact that as you move over the globe, it changes. But it changes very slowly. So, like, the difference in variation between Noroton and Newport isn't big enough to worry about. It's like maybe half a degree. So it's almost too small to measure. So to that extent, there's no relationship there between distance and variation.
Okay.
Yeah. All right. Should we finish this off? Okay.
I think everyone's muted, so.
So cheap.
All right, let's see if we can bring some people back in. Oh, there's everyone. All right, guys. So
Make it really thick.
that's all I've got. If that's all you've got. So good luck. Good luck signing up for the test. Email me with any questions. And good luck on the race, too.
There's a pink one.
All right?
Damn it.
All right. Thanks, Camille. All right. Thanks, everyone. And glad we could do this from home. So hope you guys have a good rest of the week, and good luck with the tests. Email questions. If we discuss them as a group, that'll help everyone out, and everyone should crush the test. So, nice work.
Sister Sam.
Good meeting you all. All right, bye.
Thank you.
Thank you.